Hello everyone, my name is Rajesh Kumar and I'm your DevOps SRE DevSecOps coach. I have close to 18 plus years of experience working in multiple MNCs around the globe and having in-depth knowledge of DevOps, SRE and DevSecOps. So I would like to introduce you one certification program in a DevOps, and that is we call it DevOps Certified Professional. Now this is a 2 months of program, 25 tools of DevOps you will learn, and apart from that you will also get the access to the LMS, lifetime access to the videos portal. It's a certification program, and you will have 25 assignments and 2 projects along with it. It's a completely weekend program, so here you have classes on Saturday and Sunday. So as part of this course, you will learn multiple things. Here you see that you will learn Linux, AWS, Docker, Jira, Confluence, Python, Git with GitHub, SonarQube, Maven, Gradle, Packer, Artifactory, Selenium, JMeter, Ansible, Kubernetes, Helm, Terraform, Jenkins, Datadog, Splunk, and Neuralink. Now, how do we, apply for this? So how can you reach out to us? So you have a WhatsApp number and email ID. So please reach out to us, and we'll help you to onboard this program. Apart from this DevOps certified professional programs, we are offering other certifications as well in a DevSecOps, SRE, and one of the very comprehensive programs which we have is in Master in DevOps Engineering. Yeah, so feel free to get in touch with us and then enroll for it. Thank you. So in this session, I'm going to talk about introduction of Linux. Okay. And then I'm going to teach you how can you create a virtual machines using VirtualBox. Okay. And after that, I'm going to help you to get comfortable with some of the important user commands, and then admin commands. And finally, uh, here I'm going to help you with vagrant. And then Linux. Sorry, I have some throat infection, so please don't mind. Linux shell scripting. So these are the things which I'm going to help you with, and we'll do that today. Okay, so let's get started. First thing, Linux introduction at a high level. Uh, can you see my screen, all of you, right?
Yes, it is visible.
Yeah, yeah. So now, first question is first question is what is Linux? So Linux is one operating system. We all know that. Windows also we have, which we are using from last so many years, and it's also one operating system. So Linux and Windows is operating system. I will not teach you Windows because more or less we all understand that. But Linux is very important for all of us for DevOps. So when we call Linux operating system, so inside that we have a kernel, and you need to know kernel. Why? Because next sessions will happen on Docker, Kubernetes, and without understanding of kernel, you will not be able to learn container technology. So what is kernel? So we know that inside a operating system we have a kernel, we have a Linux kernel, we have Windows kernel. So what is kernel? So kernel is nothing but a programs written in C. Simple way. This is just a program, and using kernel only, which help us to communicate between the human and device hardware. Hardware means when you say CPU, RAM, storage, different input and output devices we have, and who's helping us? Kernel. Okay, so If you look at this here, so kernel manage all of your hardware, and also on top of kernel you install certain applications, user applications. So where the kernel programs run. So basically it is a portion of the operating system code that always resident in memory is memory, okay, and facilitate interaction between hardware and software component. Now the question is when the kernel program run. So kernel is one of the first program loaded on startup after the bootloader. So if you see that these are the types of kernel which we have. Our kernel, the one which we are using, is a monolithic kernel. That means everything you have it one go. Sorry. So I don't know how many of you have understanding of that. Like even Android is a kernel, a Linux kernel. Do you know that this Android, the one which you are using in mobile, that is also Linux kernel. Okay. So what are the primary role of kernel? What they do? So they manage all of your tasks. Um, they manage the sync and communication, memory management, which process should have how much memory, timer management. If there's an interrupt or event handling, it is managed by kernel only. All the devices, hardware and all, it is managed by kernel. So in short, yeah, CPU and caches uses managed by kernel, file system, network socket, memory management, device devices input output and all is been managed by kernel. Now, anyone have idea who's this? I mean, who's this guy? All of you, who's this guy?
Yes, he's Linux
Yes.
uh, li
So his name is Linus Torvald.
Linus Torvalds.
Yeah,
Yes.
yeah. He is the father of Linux kernel. Okay, so yeah, it's a free and open source and developed by Linus Torvald. Now, this Linux kernel is used many places. We are using in server, but you can use in the personal computing, mobile also, embedded devices, supercomputers and all everywhere you can use it. Now, when I ask when the kernel is loaded, running, so we talked about the bootloader. So when you start the system, Windows or Linux, I mean hardware, basically you start the start button. So the first bootloader is loaded actually in memory. Okay, bootloader you have in Windows also. I mean it's irrespective of what operating system. And bootloader decide what program, what kernel should be loaded. So bootloader is also spelled as bootloader or called boot manager and bootstrap loader. It is a computer program that is responsible for booting a computer. Okay. So when you press switch on, then first bootloader loads, and then bootloader internally they load the kernel. So when a computer is turned off, is software including operating system, application code, and data remains stored on non-volatile memory. When a computer is powered on, it typically does not have an operating system or it's loaded in RAM. So this is something which important to understand. Look at the flow of it. When you power on, a ROM random only memory get loaded with the help of devices, booting devices like it can be your storage or something where the kernel is lying. Then bootloader loaded and then bootloader load the kernel and after that your platform. So this is the flow of kernel. Powered on, load bootloader in ROM, load kernel code in RAM. ROM and RAM. Read only random access. Remember that. These are the little bit internal of bootloader. I'm not getting into that. It's not important for us right now. So I'll just skip it. Now this is very important. In Docker, you will have to experience it. So when you look at the any system, whether it's a Windows or Linux, it does not matter. There is a two space. Now what is space? So you can say it's like an area where the programs run. So there is one space called kernel space, and there is one space called user space. Okay, it's two space. Now what is used for it? So basically, computer OS usually segregate virtual memory into user space and kernel space. That means all the virtual memory which computers get it divided into the two part, user space and kernel space. So user space basically where all the user program will run. Mind it, all the user program is running user space. Kernel space where all the program will run. How they communicate, that I'll discuss it sometime. So here kernel perform its task such as running processes, managing hardware devices such as hard disk, and handling interrupts. And in this protected area, this is called kernel space. I said protected area. Why? In the kernel space, whatever the program you run, it should not be disturbed. Because if the kernel is getting disturbed, your server will get disturbed again. So that is a problem. So it should not be disturbed. Now, what happens when you run your applications? You are using your laptop, right? When you run application like a browser, some WordPress, you play some players, video, audio, and all kind of things. So that is running in the user space. Mind it. So here, all of your process running in the user space, all of the process which is related to managing the operating system kernel, that is running in the kernel space. Are you understanding, all of you? All of you? Hello?
Yeah, Rajesh.
Yes,
Yeah.
Rajesh.
Yeah, yeah.
Yeah, and remember that in Docker we'll have a discussion on this again, follow-up discussion. So kernel perform its task such as running process. I think it's a repeat. So now why kernel have user space and kernel space? And the reason is protection. What happens? User space, any processes which you run, it should not destabilize the operating system, which is run by kernel. So what happens? All the process which users run has a scope of only user space. They cannot interrupt any process run by kernel. So that way user process cannot hack any of the kernel processes. So that's a major reason. So here if you see that this separation prevent user data and kernel data from interfering with each other, causing instability and slowness, as well as preventing malfunction in application from affecting other application or crashing the entire operating system. So look at this here. This is the image. When you see that all the processes, virtual memories, you have kernel space and then user space. Okay. So if you see that very carefully, user space, all the process run by user. You see that user. So this user space and kernel space both by managed by supervisor. But the only thing is user process cannot access the kernel process, so that way system will not disable. So that is a reason for it. Look at this here. So now the question is, in this image you should see. So understand this, kernel process have all the processes, kernel space has all the processes, and kernel only, remember that, accessing the hardware like RAM, CPU, storage, network, input and output. So now the user process, to run user process, they need a CPU, they need a RAM, they need a hard disk, they need a network. So how this user process will get? So the question here you should be asking, how the process run by user will get CPU, RAM, storage, network, input and output from the kernel space, because all the devices is managed by kernel space. Correct now? Hello? Hello? Hello?
Yes,
Yeah.
sir. So
Yes,
can you
Yeah.
yes, you
repeat
are
again?
audible, sir.
We can hear
Yeah.
you.
Yeah. So here the important thing is we call it system call. Let me tell you, this is a very important interview questions also. So you will be asked in the Linux kernel, you have a process running and process required some CPU, RAM, disk and all stuff like that, input and output. How user processes gets from the kernel. So the answer is we call it system call. It's not a generic word. It's call in a kernel programming actually. We call it system call. Okay. So remember again, I'm saying all the processes which you run by user like a browser, they need CPU, RAM, and all this info, storage and all. So they ask user process ask kernel space process, RAM and disk. How they can get
So,
it? They make a system call.
so
Okay.
here is user. I have a question, sir, right here. So, as a user process, right? If the user send any call or any request to the kernel space, it first goes to the RAM space, correct?
LAN. No, no, there's no LAN. There's no interrupt. It's all
No, I
happen in
said
the same.
RAM. I didn't say LAN.
Aha,
I
yes,
said
yes.
RAM.
Yeah, 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 yeah. Okay. So here in detailing actually the same image in detail. There is one process which is running bash. Bash required process ID, RAM, UID, network, CPU, and all this thing. So how they get it? So there is a different functions are there. These are the functions. So like that in kernel, there's so many functions. Using these functions, they access the resources which is running on the kernel space, and they get this, and then they run all these applications. Remember that. So let's say if you are opening a file, you run one command. You log into your laptop and you run one command, cat command, which is like to display the content of the file. So this will open up one method in kernel, open this method, and then they will involve the storage file system, different components. So remember that system call, overall we call it a system call. System call has so many functions for all this thing. So both are separate spaces where the programs run. So all the kernel related program, operating system related program runs in kernel. All of your programs run in user space. Kernel space, user space.
Rajesh, Rajesh sir,
Yeah,
I have a question.
yeah,
So, sir, system call is nothing. It's just a function that we use to interact with the kernel space, right?
yeah. We call it this one system call. Okay.
Yeah.
Okay, so look at this here, another visualizations. You have a hardware. On top of that, you have a Linux kernel, which is running in the kernel space. And then your program is running in user space. Same. Again, user space, again access the kernel space, ask for it. And then kernel space, all the program running, ask for the hardware and get you the all this stuff at a high level. This is in detail. I'll just skip it because whatever I wanted to tell you, you know that. This is a little bit more elaborative image. I'll just skip it. This is again more deep dive image. I'll skip it because so many things we have in this. These are the function actually if you see that. Stat, splice, dup, rate, open and all kind of things. Okay, so now you have understood kernel. So Linux architecture, primarily you know that hardware, kernel, shell and user. These are the layers you have. Okay, so kernel space and user space again, I'll just ignore it. System call, always remember that all the user program talk to the kernel program using system call. So in computing, a system call commonly abbreviated to syscall. Sometimes we call it system call, sometimes people call it syscall. Is the programmatic way in which the computer program requests a service from the operating system on which it is executed. Okay, so it can be any of the resources which is managed by kernel. Okay, so look at this here. This is user space again, kernel space, syscall interfaces. Okay, so now we understood the system call. These are the services provided by system call: process creation and management, memory management means you want to have a memories for it, file access and directory and file system management, input and output protection, and networking. Okay, so these are the different types of system call. I'll just ignore it. Okay, and some of the ABI, API, and all conceptually internal to the kernel, I'm ignoring it right now. Okay, so now here, if you see that some of the example of system call. So can you see this process control? All of you, my cursor, all of you.
Yes,
Yeah.
yeah, yes, you can
Yeah.
say.
So this you need to know a little bit of it. Okay. The rest of these are the methods actually available for the system calls, but only this is important for time being. So here, process control. How this process is being controlled. So these are the method which you see. When the process is created, is new, then it's ready, then it's running, waiting, and terminated like that. This is the workflow. So example of syscall call process. So here, if you see that this is the workflow. I'll simplify this one in simple way. Uh, Wait a second. I don't want to complicate right now too much. Uh, Wait a second. I'll just directly go to then which we have. Process. So process and thread. So what is process? So if you see that image, you have one process and then you have multiple thread. Okay. So what is process and what is thread? If you see that this image also, CPU is given to the process. Look at this. CPU is given to the process and each process have a multiple thread. So the question is what is process and what is thread? So process, see any program you run, let me show you in real. So if you go to the task manager and if you look at it very carefully, let me go to the details. And if you look at it very carefully, in order, these are the running programs, okay? These are the running programs. In Windows only, all here, but concept is same. So these are the application which is running. Hell lot of applications. Okay, these are the running. See that status running. Now, if you look at it very carefully, each process which is running, they get the one PID allocation, correct now? Here, okay, PID means the to identify this particular process. And now this PID, if you see that very carefully, each application is running with a certain users. You see that here? There's one user associated with it. You don't see that any process which is running without user. So here this is my user Rajesh Kumar and this is the system user. There's a local service user, network user. And if you see a little bit more carefully, each PID get a CPU allocations and RAM allocations. Okay, so here the question is what is process? These are all the process 1, 2, 3, 4, 5, 6. Are you understanding, all of you? Hello?
Yes, sir.
Hello.
Yeah,
Yeah.
yes, you can
Yeah.
understand.
Now, if you see that there's so many SB hosts, so many SB hosts. What is this? So let's try to understand this one. The process is a computer program, simple, under execution, under running. All this which I showed you is a process. Linux is running many processes at any given time. You can monitor it using the command which is called ps command. I showed you in Windows through UI. In Linux, you have a ps command to look at the process. Okay, so that is a process. Linux processes are isolated, mind it, isolated, and do not interrupt each other. That means here these processes will not interrupt each other. These all are isolated processes. Okay, so now process with the PID you can identify any process in Linux. Same with the Windows also. Internally, the kernel uniquely allocates this number, and remember that kernel allocate this number and release it for the reuse. Again, release it. It's releasing it, the number. Once the process died, the number is released to reuse it after the process exists. Let me show you in the Linux some processes so you'll get comfortable. Here this is the Linux, okay? See here, all the processes, EAF. See here, hell lot of processes. Look at this, owned by root, PID, parent ID, and this is applications is running. And if you look at this, every process running with a certain root, certain users. Okay, so understand this way. So since many processes are running at any given point, given time in Linux, they have to share the CPU. Process of CPU, the process of switching between the two executing processes on CPU is called process context switching. What is that? So if you look at this image here, what happens? CPU, I don't know you know or not, but CPU can be provided only at a time to one process. I repeat, CPU can be provided. See, RAM is there, so this process running. But to function the process, you need a CPU. So in order to work, in order to let the process work, you need a CPU. And CPU can be provided only at a time, one process. Are you understanding, all of you? No, but you know what? You will say, Rajesh, I am opening browser also, and I am opening this also, and I am opening that also. If you look at this here, you see that here very carefully. Look at the CPU. See here. If you look at it little carefully, you will see that all the programs is running, but actually CPU is provided. See that? Are you able to see that? Is provided to one of the applications most of the time, and remaining are 0, 0, 0, 0, 0. Correct now? Hello?
Yes,
Hello?
sir.
Yeah.
Yeah. So, but what happens? Whichever applications you open up, they demand CPU. The moment, let's say I open this one. So now they demand, see Chrome has come up. Look at this very carefully. See Chrome has come up somewhere. So whichever applications you access, you use it, that requires CPU. But the problem with the architecture is you can only provide CPU to one process at a time. But you know what? You don't realize it because CPU switching happens so fast to one process to another process. You don't realize that system is waiting for the CPU. It's happened in a so fast way. Okay,
Mm.
so fast way. So that's way. So it you don't realize it. So here again, same thing I was talking about. The process of switching between the two executing processes on CPU, this process is called process context switching. So process context switching is expensive. Mind it, it's expensive because the kernel has to save old things. So whatever I'll put it in this way. See, I am using PPT and then I am using browser. So now kernel has to store what is the state of my browser, and then kernel has to store what is the state of my PPTs. So they have to store it. So while switching the CPU from one process to another process, the memory loss happen. I mean that you see is expensive because the kernel has to save old registers and load current registers, memory maps and other resources. So because of that, they lose the CPU. Are you understanding, all of you?
Yes.
So what happens? That is where the thread is coming into the picture. Remember that I was trying to tell you what is a process and what is a thread. So if you see that this image, you have a process and each process you have a multiple thread. So now what is a thread? You understand the process. So what is a thread? So basically, you know what? Thread is also a process only, but it is a lightweight. Okay, it is a lightweight. So process can do more than one unit of work concurrently by creating one or more threads. Okay, threads. So what happens? These threads, being a lightweight, can be spawned quickly. So one thread which gets a CPU, and thread has a one process which gets a CPU, and each process you have a thread, so they can be spawned quickly. So if you want to see how it works and all, so you can look at this PID, LWP and NWP. So where the PID is a representation of unique process identifier, LWP unique thread identifier inside a process, and number of threads for a given process. So let me show you this one. This is the Linux machines, and here if you see little carefully, uh, let me run the command ps elf. Look at this very carefully. So if you want to know how many threads you have, so here you will get to know. Look at this 1111 right now, and here somewhere. Look at this very carefully. This is a vault server I am running in this, and you have they have a 8 thread actually. So that's one process, 8 thread. So this LWP represent your ID, okay, and then process ID, and then how many threads you have, you can see that here. Okay, in Linux you can see like this. So thread here, same thing which I was showing you. Okay, so in process you may have a multiple threads, single thread or multiple thread. So any thread created within a process share the same memory. That's the advantage. You give one memory to one process, all the thread of that particular process share the same memory and the resources of the process. In a single threaded process, the process and threads are same as there only one thinking happening. But you have a multiple thread also, one process multi-thread. So in a multi-thread process, the process has more than one thread, such as process accomplishes multiple tasks simultaneously. I was showing you multiple thread also, or almost at the same time. As we know, the threads share the same address space of the process. So if you have a, let's say, multiple thread of the process, so thread share the same address space of the process. Therefore, swanning a new thread within a process becomes cheap. Okay, remember that. Just to save wastage of CPU and RAM for the process context switching, what they do, what programmers can do that they can create a multiple thread of the same process. So switching between the thread is becoming cheap. So in terms of system resources compared to starting a new process, it's very cheap. So that is the reason you might see that people, when they write a program, instead of creating a process, they create a thread of the same process so that application can be faster. Thread also can switch faster since they have a shared address space with the process compared to the process in CPU. Internally, the thread has only one stake in the memory and they share the heap process memory with the parent process. So this is something, you look at this image. Here you have a one process and you have all the data which is available, and thread is using that all the data available. And here if you look at this multi-threaded process, you don't have to switch the context. This is the one thread, one thread, and they have their own again data. So that way it's become a faster. From one thread to switching to another thread is becoming faster things. Process internals. Okay, so thread internals, I'll just skip it this one because not too much discussion you needed to know. Slowly you will get it understanding of this, and scheduler also not needed to know. Yeah, you actually you can do that much more than that, but that is something which you have it. So now what we understood so far, I will just sum up. First of all, what is operating system? What is kernel? Then different space of kernel, which is like user space, kernel space, how this user space and kernel space works, something about the process and threading, and the role of kernel and types of kernel and so on. Are you comfortable, all of you?
Yes, audible.
Yeah. So now guys, this information you should ask where this will be helpful. So you know what, this information will not helpful for you when you are working on your DevOps work, but when you get back to the Docker container technology, then understanding of the kernel how it works will help you. Also, if you are trying for some broad based companies interviews, they will ask you this question. So please remember the some of the things which I want you to remember: the component of kernel, spaces of kernel, how the process running in the user space and the communications request to the kernel space. Remember the system call, always remember that. Every interviews they'll ask you. They'll ask you what is the process, what is the thread, and how the process and thread is useful for it, how the threads are useful for it, and in which way, all this stuff, and so on. Okay, so now let's get into the second topic which we have is virtualizations. So guys, we need to have one Linux operating system. Now the scenario is how can we get it? So what you can do, you can install the Linux operating system in the hardware itself. Hardware, when I say, that means I mean to say your laptop, directly laptop. But actually what you want, you have a laptop and you are very comfortable with Windows, so you don't want to replace the Windows with Linux. Yeah, because of many other reasons. So what do we do in this case? So in this case, what we will do, we will use the virtualization technology. Virtualization technology. Now what is a virtualization technology? Anyone would like to comment on it?
It's a virtual computer. It's like
Yes.
copy of the computer, or we can run in the virtual machine, Windows, Linux,
Yeah. So what is
with the
happening, I'll tell
help
you.
of ISO image.
Yes, yes. So what is happening here? Let's understand this way. So this is the hardware layer. Okay. So here you have CPU, RAM, hard disk, and all stuff like this. Is the hardware layer. Okay. On top of hardware, what we do? We install the operating system. Correct now? An operating system. Each operating system, you have a kernel. This is something which we do. When you say operating system, it can be Windows also, Linux also. That's not a problem. So you have a kernel. Now on top of kernel on operating system, what you do? This is you have a user space. This is the user space, and you run a hell lot of applications: browser, PowerPoint, Notepad, this, that, and all this. So all the processes running here, they ask kernel, hey kernel, give me the CPU, RAM, storage, the blah blah blah. This is the user space, kernel space. Now, but here the problem is, this is the operating system, let's say Windows. This is the Windows. And now you want Linux. So what to do? So then there is a one software has written, and this category of software we call it hypervisor. What we call it? What we call it? Hypervisor. Always remember that. This category of software. There's a software which is running in your displays. You will be running in here, hypervisor. Okay, this software will be running in the user space. So what this software will do? This hypervisor, there are multiple options. Can you please name it if you know that, all of you?
Hypervisor B, I know, I don't know other things.
So this hypervisor is
VMware
like
VirtualBox,
VMware, yeah,
VirtualBox.
VirtualBox, yeah, and Hyper-V from Microsoft. These are the hypervisor. Okay, multiple we have so many software we have hypervisor. Just search in
vSphere too.
Google.
Is it
Yeah,
a vSphere?
yeah. So list of hypervisor you have it. These are the popular one. So what this software installed on user space? What this software do? They create an environment, something like this. They create a VM, virtual machines. One VM they created, two VM created, three VM created. And all this VM is managed by this hypervisor. What happens? This hypervisor is setting up operating system here also. Mind it, operating system in the VM itself. Now this operating system, you can have Windows or Linux. Now in order to run this operating system or this operating system, you need a CPU, RAM and storage. So what this hypervisor is doing, this hypervisor directly talking to the kernel to get the allocation of CPU, RAM and storage. Are you understanding, all of you?
No, sir.
Uh, for time being, I'll put it in this way because I don't want to get into the hypervisor. The reason is this is a very old technology from last 20 years and somehow we are getting out of it. So for time being, I'll tell you in this way. uh, one more example. One more
Rajesh,
example. Huh?
there is a lot of background noise from, is it from your end or some?
What kind of noise you are seeing? Because I'm in the empty room actually.
Dog is barking a lot. Oh,
Yeah,
Dogs
I
are
think.
barking.
Yeah. I think it's just a second. I think now I noticed actually. So just let me close my window. Hold on. Yeah. Is it okay now? Hello. Is it
Better
okay
now.
now? Yeah.
Better. This is
Uh,
better.
yeah.
better now.
The prob. Yeah. The problem is this the dog which was barking, which is around 500 meters from my place. But surprisingly, I'm staying in this kind of place where the noise, I mean pollution is not there, any kind of pollutions, so you can see or you can hear very clearly. Okay, so I was discussing something, which was that?
Uh,
Hypervisor.
that's a
Hypervisor.
hypervisor with virtual
Yeah.
machine.
Yeah. So I'm not deep diving into that, but at a high level I must share with you. So here, what is concept, I'll tell you. So let's say I want to run one software. Which software? I want to run, let's say Apache. Okay, one web server. So I have option number one. What should I do? There is a one physical machine I'll set up, two physical machine I'll set up, three physical machine I'll set up, and four physical server I'll set up. And then what I will do, this is a different network, IP address different, port number same, IP address different, port number same. I'll create one load balancer here, different IP, same port number, and then my users can access through DNS to these applications. Are you okay with this so far?
Yes.
So what has happened, if you look at this utilizations for my server, okay. So if I see that my peak time utilizations was 80%, peak time, but the traffic when was very less, utilization of this server was 30%. Now if I look at the average utilizations, let's say it's a 40% or 50%, whatever it is. Average, on an average utilization of when I say utilization of like CPU, RAM, storage and all this. So here, if you see that, just imagine you are just talking about the 4 server and the wastage is almost 60%, correct now?
Mhm.
Hello? Hello?
Yes,
Average
yes,
utilization.
yes.
Yeah, we can hear
But
you.
and multiplied by thousands of server which is running in data center. Look at the wastage, so much of wastage. Now this, when you have a low utilizations, this server you cannot give it to someone else also. So what to do? Then we have one technology which we have got it, and that technology we call it hypervisor, virtualization. So what in that they do that? They have a hardware, large hardware. On top of that, they install the operating system, and on top of that specific software installed. And this software, what they do, they create a multiple virtual machines. Depends on requirement and how much time it takes to create a virtual machines. Few seconds. Okay, so one virtual machine, two virtual machine, three virtual machine, and what they do, these servers they allocate, and in the virtual machine you have operating system also. Okay, so this is the hardware, this is a base operating system, and this is the hypervisor, and this is again in a VM you have an operating system again. And now what you can do, so let's say you need only two machines to run your production, so give it to this machine you give it to the dev team, another machine you give it to the different department, so that way you can share the same hardware for the multiple purpose. It's a different machine, different machine, different machine, different machine. So this is called virtual machines. This is called real machines. Are you understanding? All of you?
Mhm.
Yeah. So now these machines which you have powered by this software, VMware, VirtualBox, Hyper-V, VMware from VMware. This is for Apple, Hyper-V from Microsoft. So using that you can create virtual machines. So today what I was trying to do, I was trying to create a virtual machines. Okay, so now if you want to read more about the virtualization, take it some of the things, tutorials on the internet. It's thousands of content you'll get it because of very old technology. It's been there from last 20 years. Okay, now you know what I'll tell you. So using this software, you can create a private data center. And you know what AWS and Azure, all of you? Azure, AWS, GC, correct now? Hello?
Mhm.
Yes,
Hello?
Rajesh.
They also create a virtual machine actually. They also have a virtual machine. So they also internally use some hypervisor, specialized hypervisor for the large scale. This is for small scale. They are doing for the large scale. So what you are going to do, let me tell you, either you go to VMware, which you can install in a desktop, okay, or you can go to AWS, which you can find in the cloud. The results is same. You will get virtual machines, and each virtual machines you will have a certain operating system, certain CPU, and certain RAM and certain hard disk. Got it? So this one which I am accessing, you see here, this is the Linux virtual machines. Where exactly this is? So this is on Azure. Here it is. So I created one virtual machine named with Vault. So this is the virtual machines. Let me show you. See this here. So
So,
either you create these virtual machines in your laptop. Why you want to create in your laptop? Any idea?
we need to like uh, multiple things. We need to do multiple things. Let's say I have a
Yes.
Windows, right? And then I want to do something with Linux or Kali Linux or Unix, anything
Yeah,
over
you will
there.
say, okay, I'll teach you many tools actually. What tools? I'll teach you Ansible. I'll teach you Docker. I'll teach you so many tools actually. But you'll say
Kubernetes.
that, Kubernetes, all these tools. And you say, Rajesh, I don't have a lab environment. So I'll say, okay, go ahead and create a few boxes. What is the problem? Then you'll say, Rajesh, I don't know how to create a boxes. You can create a boxes VM on AWS. You can create on Azure. You can create on Google Cloud, or you can create in your laptop. So then if you want to create a VM in your laptop, then you'll say, how can I do that? Then I will say, hey, we have a software for desktop. This software, VMware VirtualBox Hyper-V. So this software will help you to create a VM in your laptop. Or option number two, go to AWS, create a VM and pay for it. Which one you want to opt for it? Tell me. Hello.
PMD.
Without further lab, right? It is best for everybody to use like VMware. So if we use AWS cloud, we have to pay for it.
Pay for it, yes. Both the places you get the same thing. Whether you install the VM VirtualBox in your laptop or and create a VM, or you get one VM created on AWS Azure, you will do the same thing. There's no difference. Ultimately, you get one operating system. This VM virtual machines can be Ubuntu, can be RHEL, can be CentOS, can be anything else also. These are the variant of Linux. Make sense? Okay, so now come to the points. Now question is how to install VirtualBox. That is the first question. Second question, how to create VM. That is create a VM using VirtualBox. Okay, and third question, how to use it. This I am going to show you in the next 15 minutes. All of you understood this?
Yes, Rajesh.
Okay, so now guys, first thing, installing is very simple. I don't think so. I need to teach you how to install it, but I'll show you that in recordings you can have it. So just type VirtualBox download. Now this is a website. Go to this, and I don't have to tell you like which package you need to download because you are on Windows, so of course you will download this package. You are in Mac, you will download this package. You are on Linux, you will download this package. Yes, you are on Windows, you will get one exe file. Click on the exe file, next, 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 and finish. You know that what I'm talking about. Installation is done. After installations, you will have VirtualBox like this, Oracle VM VirtualBox. Click on it. Now, if you open up, you see that I have a little older version. That's okay for me. And you see that so many left side, Windows, Ubuntu, Prometheus, AppDynamics, Tomcat, Dynatrace, Jenkins, SonarQube, Splunk, Dynatrace, and so many. These are the VMs actually, virtual machines. I have created it, but you will be having none. So you have to create it. How do we create it? So in order to create a virtual machines, first thing, mind it, this is important. In order to create a virtual machines, you need a OS image. Okay, I repeat, you need OS image. If you go to AWS also, they will ask you, hey, which image you want it, which operating system you want it. Azure also same way. So VirtualBox also will ask you, hey, give me the image. So what you will do, download the image. How can you do that? So I'll go to the Google and search for download. Which operating system you want? Download Ubuntu image. Enter. That's all. This is the URL for it. Okay, but you know what, guys? If you read it, this is the desktop image. Desktop image means you have a UI of Ubuntu. Whenever you see the desktop, that means you'll have a UI. But you know, from today onwards, please avoid the UI. Okay, get a habit of command line for everything. So the desktop, I don't want. Server, non UI based, I want it, and I'll download it. The size will be around 4 GB. Okay, it will take, I think, depends on your internet speed, 20 to 30 minutes, whatever it is, and then you can download it. Now I have already downloaded. Where? Let me show you. So go to download folder, go to software, go to VMs, and these are the images I have already downloaded. Look at this. This is a 1 to 22. This is also 1 to 22.04.4. CentOS image, Windows image, and all these things I have downloaded already. So now if you want to download CentOS, just type download CentOS image. These all are free image, okay? Don't worry about that. And here you can download.
Rajesh, I have a question.
Yeah.
I was trying to download the virtual box. So after I downloaded it, I want to install, but it says Oracle VM VirtualBox needs Microsoft Visual C++ 2019 with distribution. What does that mean?
That means the that current you the .NET write version is not installed actually. So just put the URL the message in the Google, you will get some Stack Overflow and some link to Microsoft website and where you can get a Visual Studio download.
Okay,
So just put it, it's easy. I know that what you're talking about, but it's just your system is not up to date. That's the reason. So you will get a link to Microsoft website where you can install Visual Studio. This one I think Visual Studio C++. So you'll get
okay,
downloaded actually. Here is the
okay,
download center.
okay.
So
Thank
just
you.
put it in this Google. Stack Overflow will lead you to this.
Okay,
Okay. So now that is done. What I was doing actually, yeah. So you can download the CentOS image also. So it's up to you whether you want Ubuntu or CentOS. I don't care. Though some very minimal difference are there, which I'll talk about. So guys, here this is my virtual box, and here this is my VM, and one of the VM I will install in front of you. Again, you need to focus on the my steps, so you will not get confused while doing it. So, anyways, recordings will be there, so don't worry about that. Okay. So new, what do you want? So what should I name it? April demo. This is the name of my VM. Now VM by default will store here. Don't change this. Now what is a type of operating system? Windows? No, of course no. Linux? Yes. They'll ask you, hey, do you know the version of operating system? So here you have Debian, Fedora, Red Hat, Ubuntu, all these things. So I'll go for the Ubuntu, let's say 64-bit. Mind it, always use 64-bit. Next, and they're asking you, hey, how much you want to give memory? So guys, my system has 16 GB memory. My laptop have a 16 GB, and I know that 2 GB for Linux is sufficient because Linux consume little less memory. So I'll give the 2 GB RAM. Next, now here they say, hey, disk you want to create now, and I'll go with the default. Yes, let it create this disk format. What is the type of the disk type it should be? So there is a three type which is supported by VirtualBox: VDI, VHD, and VMDK. Now I know that you may not have an understanding of this type, but in later point of the time I'll give you an assignment. Try to find out what is the difference between these three. It's assignment offline. Next, let's go with the default. Now, do you want this type disk size to automatically allocate it as you use it or a fixed size? I will go for the dynamically allocated, that as we ask for more size, automatically it will get enlarged. Next, now what is the disk size you want to give it? So go for 20 GB or 30 GB. That's good for your demo. 30 GB, remember that. Okay, so here you have to use this one. Okay, this one, 30 GB, and then create it. That's all. So now guys, here, where is that? I lost it. Here. Can you see the bottom section of my page, all of you? Mind this screen?
Yes, we can. I see it.
Yes, wonderful. So guys, this VM is created. But you know what? this VM is equal to empty laptop without operating system. So now the question is, you have to load the operating system. How do we do that? I don't know how many of you have installed your operating system in your laptop. It's something like that you are doing now with the VM. So the question is how to do that. So I'll click on the VM and then I'll click on the setting. I'll click on the storage and I'll click on the empty. Don't worry, recordings will be there. Understand that theoretically, conceptually. Click on the empty. And there is one CD button you see or the at the somewhere my cursor. I'm hovering over it. Here. Hello.
Yeah, listening, we can hear you.
Yeah. So click on this. And here you see that few ISO image is already there because I have used in the past, but I will not use this one. I'll choose a disk file. Where is that? These are the one. Which one I want to use it? So let's go for this one and open up. It's a 1 to 20, okay, not 22. It's 20. Open up and click OK. That's all. So now I set my base image, operating system image, and then I will start this VM. You can start and stop, restart all this thing, you can do that. So this is the VM April demo. I'm starting it. Now installation process will start. So what I did theoretically, I added the bootloader, that image. Remember that in the Linux kernel, I told you bootloader load your operating system. So this time I load the image, and image will create a kernel, and then that will be added automatically by default. So now they are checking. There's some pop-up, you'll get it. Keep closing it. Okay. Now I must tell you one thing which is very important. Very important. Guys, what you see somewhere in the cursor? Can you tell me what is exactly you see? Where I am cursor having? What is written? Hello?
Can you say
What
that again?
exactly?
What do you mean?
I'm hovering cursor at certain point. What is written over there? I want you to read it.
English. Oh,
What is that?
Right control. Right control.
Wonderful. Always remember this right control. So what I was trying to tell you guys, if you click inside the screen, you will lose the cursor because your cursor will be activated inside it. You will lose it. Why you have to click inside the screen? Because you have to select all this option to install operating system. Now you'll say, how can I come outside? How can I come outside? So click on the right side of control and you can come outside. Very simple. You go in, click on inside the console, this black console, you will lose the control. How to come out of it? You have to press keyword right side of control and you will come out of it. Always remember, don't get frustrated. So here I am clicking inside this. I'm using tab right now, English, enter. Now continue with updating or without updating. Let me tell you guys, if I go with the updating, that means operating system new will be downloaded from the internet. But that is going to take a lot of time. I don't want to wait for it. So I'll continue without updating and enter. Now they'll ask you, hey, are you sure about this configuration? Yes, enter. And they'll ask you, hey, do you want to add this Ethernet and all? Let it be continue, done. They'll ask you, do you have a proxy address for internet? Done. Do you mirror if you want to give it? Done. No need to change anything. And finally, these all sections you have to do that. And if you want to encrypt that disk, you can do that. But right now, everything is done. No need to complicate. And here, whatever you get it again done. I'm not changing anything. Are you sure you want to continue? Yes. Now here you have to give the name. My name is Rajesh Kumar and here your server is I'm creating for the demo. So I just name it. What is username? So Rajesh. What is the password? Rajesh123. Rajesh123 and done. Do you have advantage token? Not required. Done. Do you want to open SSH? I must tell you, you have to check this one. install OpenSSH, because how to connect, if this is not installed you will not be able to connect it, so again you have to install separately. So you please check this one, and I'll put this space for it. Yes, space, remember that I'm telling you.
What is actually what is open SSH?
OpenSSH, I'll discuss little bit of this thing in this topic, how to use it. Okay, so for time being you have to click space on that and then tab to done, enter it. Now they're asking, hey, we have lots of software for it, do you want to install it? Nothing, I don't want to install any of this software. Done, OpenSSH is only required. And now everything I have done it, now it will take 10 to 15 minutes to configure your VM. Understood now?
Yes.
All of you, now this VM, let's wait for it. Okay, let's wait for it, and meanwhile I'll move on to the next topic, and that is called how to use it. Okay, so now guys, what will happen, I lost the console, huh? So what will happen, please understand theoretically, this is your laptop, and this is the VM you created 1 and 2. Now you know what, this VM, you want to connect it, you want to connect it. So this is you, let me create your image. You are inside your laptop right now, I'm inside your laptop, but you want to connect to this VM or this VM, correct now all of you? Hello?
Yes, Rajesh.
Yes. So now the question is, how can I connect? So see guys, if you are in Windows, me, I'm putting in a very simple tabular format, me in Windows and VM is in Linux. Okay, me in Windows again, and VM is Windows. The question is how to connect. So option number one, console here also, and Windows console, the one which you are using every day and night, here also. How can we access the console? So this is the way you can access the console. So once the operating system will install, here only whatever you see, you will see the command line. It's called console. Or you will see something like a Windows console. Here Windows operating system will be there. Okay. For example, let me show you Windows. Do you have Windows, anyone? I have Windows. Let me start this VM. This is the old VM which I had created already. I am starting this VM, and then you'll see that. Let me show you, then you'll get comfortable. I'm starting this VM. New VM. It's not creating. I'm starting that existing one. Okay. See here, this is booting a Windows machine. So this is called console. I don't think so I have to teach you how to work with the console, because you guys are using since ages. Okay. So let it come. Here is a Windows. Now log in. Control Alt Delete. Pass this input. Here input keyword. Control Alt Delete. Put the username. I don't remember the username and password. Maybe Rajesh 123. Let me try. No, something like, I forgot actually, to be honest. So understood. Now right side and click. Right side and control and come out of it. So this is called console, and you are comfortable with it, right? But get a habit of something else. So when you are in Windows and you have in Linux, then connect through SSH, because it's Linux. And when you are in Windows and you want to connect Windows, then connect WinRM or RDP. Now, what is this then? So here, what is happening? Mind it, this is a protocol. WinRM is a protocol. RDP is a protocol. So using that, you can access the VMs which is inside it. So here, this is the SSH server is running. That's the reason I reminded you this Linux SSH server is running. So when you talk to the SSH protocol, you can connect to this machine over the network. And when you do the RDP, again you can connect those machines, you can come inside it. You can come inside it using SSH. And then you can run any commands, whatever you want, and then do it over the network. This is the network. Are you understanding, all of you? Hello? Hello?
Yes, yes, we can hear you.
Yeah. So guys, let's let's get this VM.
Rajesh, sir, can you repeat it again about the SSH? Like,
SSH is a protocol, WinRM is protocol, RDP is a protocol. I'll show you the demo anyways. I'm waiting for this to come up. Okay.
So WinRM, right? What is the port number that's running in the WinRM?
I think 5584, something like that. Just a second, let me get
Okay,
it.
okay.
Something five starting with five. Port number 595985. Yeah. So HTTPS 5986 and 5598. RDP port I think 38 something like that. 3389. Yeah, 3389 like that. SSH port 2020. 22. This is the
Is it
22.
is it TCP is a protocol or is does TCP has a port? No, right? That's not the three-way handshake protocol, correct?
TCP is like a kind of like network protocol.
Okay.
So these are specific protocol we have it. So for that IP address protocol, default protocol, actually,
sir,
port number.
what is the use of these SSH and RM? Like,
Okay, I'll put it in this way. When you access a website, what do you do? HTTP, correct now? And then you put the
yes,
address of www.devopschool.com, right?
yes.
Amazon.in, like that. So what is HTTP? Find out this answer
Hy-
for this, which you use. So
Hypertext
HTTP is
transfer
also,
protocol.
uh,
Protocol.
HTTP is a protocol for accessing what? Web pages over a network. Simple. Network means DevOps School is a network. Amazon.in is a DNS network, DNS entry for that. So it's like over the network. So you get a web pages loaded. So here SSH protocol, you get the SSH shell get loaded, the one which you can work with. WinRM also get PowerShell loaded. RDP, you become a console, you logged into the console of this. So like that.
Okay.
Okay, so let me check this. It will take little time. And what is happening right now, installation is completed, you see the top, but update is happening, and which I don't want right now. No mode of it. Cancel and restarted the machines. So do you remember that what was the password? Rajesh123, right? Root Rajesh and Rajesh123, correct now?
Yes, sir.
Yeah. So guys, the question is, now focus on one topic, and that is how to do SSH. That is your question. How to do SSH to a machines. So first of all, you need to have IP address or DNS name. I will get it. I'll show you how to get it. Username Rajesh. Password Rajesh123. But you know, guys, you can use also keys also, keys, PEM keys. So guys, when you go to AWS, okay, AWS, and when you create a VM over there, they will give you the key, they will not give you the password, though you can set that password again later on, but they will give you the key. So how to log in using password? So if you type on the command line ssh username at the rate of IP address and enter it, this way it will take you the password. If you are trying to log in through the key, then you have to use key file, something like this. Okay, so now what I have done, let me show you. Anyways, I'll show the demo, but I want you to spend some time here, and it's very important. Whatever I'm showing you is very important. Okay, so here just type SSH, enter, and there's one tutorial I want you to look at this. See here, this tutorial. Okay, so how to log in Linux server using SSH. Okay, so this tutorial, you please look at this. So first of all, step number one, install one of the client, SSH client. You can use the git bash also, putty also, super putty also, mobile extreme also, m remote ng. These are the
Where
client
can I
software.
start that things?
Huh?
In your website? Where can I start
in
that one? How to use?
in your laptop here, this is the putty will be here, mobile will be here, this is the place, this is you. Okay, so now install this putty is good to go ahead. Okay, so install the putty. After that, how to log in, you have to decide. You want to log in with the username and password or username and the key. So if you want to use with the username and password, use this one. If you want to use username and the key, so this is the format you have here. Okay, so this is the complete information you have here, and also this demo you must watch. It's very important, all of you. Okay, so this is something which you can figure it out in the recording. Now what I have, let me do that. So right now this windows I'll shut it down because I don't want my machine to be slow right now. Stop, power off. And now I'll go to my Linux, which is April demo, and if you see that here, why is taking up? Okay, rebooting is done, no? Install complete. Okay, let me reboot that. It's confusing, so I'll just reboot, shut down, and restart. Normal start. That's all. So I started this machine. That message which was confusing. So I'll restart the machines. And you see here, let it come. And guys, once the VM is up and running, you have to do few things. What you have to do? Let me tell you. So you have to go to VM here. Let me see if VM has come. Oh, it's taken again installations. Still okay. Yeah, almost done. Yeah, wait for it. Ubuntu, almost done. So you should get a prompt for username and password. So if you get it, oh my God, again it started. Okay, there is a problem here. Again it started something which I was not expecting. Okay, again it's starting. Why it started again? Okay, maybe I was having a little less patience and I restarted without it finishing it. So again I'm doing Rajesh. Okay, so once you have to wait for, and after that once you get it, let me start the new image, new which is ready, which you'll have to wait for 15-20 minutes, and then start this image, this VM, which is all completed. So now I'll show you that once the ready things is there, how can you access. So let's wait for it. This is the new VM, this is another VM actually, which is almost ready. Mm, yeah, this is ready VM.
Why it is so small, right?
Yes, this view is small. I'll just help you to have a bigger font using putty. I'll tell you, I'll show you. Okay, so this is the one, this is the machines. You see that here. The username is Rajesh. Password should be Rajesh123. Yeah, wonderful. So now guys, this is the VM. What you need to do, whatever I said, you have to do that. So this is the VM. Let me shut down this VM. This is not required anymore. And after this, go to this VM. go to the setting options, and here go to the network, and here you will have a NAT. I repeat, you will have a NAT. Then you have to go to the bridge. Now question is, what is a NAT versus bridge driver, networking driver? Take our notes, it's assignment, you have to do it offline. So bridge, and click OK, which was already done, so I just showed you. Now what is IP
Give me a
address?
second. Just give me a second. So
Yeah, so what is IP address? IPA. So guys, can you please tell me what is IP address, if you can see that, all of you?
sorry, guys.
172.17.01.
No, that's a local IP address. Local IP address.
Oh,
Look,
192.168.131.
correct. So what I'll do, I'll install the putty which is in my laptop. I'll go to the putty. I'll open up 192.168.1.31. That's my IP address. And now I click on open. Now what is username? So let me improve the view so you can see it better. All this is in recording, you can try slowly. Rajesh. Password is Rajesh123. Now you see that I have logged into Linux box, which is hosted in my laptop. This one, if you see that last one which I logged in, this one I'll show you. This is logged into Linux box hosted by Azure. Same way you can host anywhere. So now whatever you want to do, you can do that. Understood, all of you?
Yeah, understood. For the network, right? We have to choose bridge adapter, right?
Yes. Okay, so
And
whatever
then
I said, you have to do in recording, and then you will get up and running. And this is your box, one of the box, and do whatever installation you want to do. I'll teach you the commands and all, but yeah, whatever you want to do, you can do that. So what I taught you so far, what is Linux at a high level, what is VirtualBox, how to install VirtualBox, how to create a VM, and then how to log in into VM. Okay, and then after that, what you need to know. So you have a VMs ready, you need to know Linux commands so you can work on it. Remember that, don't expect the UI, this is not good practice. So first you have to learn the Linux command, and then you have to learn shell scripting. Understood, all of you?
If you would have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.